Good morning to everyone. Now, discuss a topic about measures of dispersion. Measures of dispersion using the standard, we can proceed now to judge several proposed measures of variability. In order to describe a frequency distribution adequately, it is necessary not only to know the center of the distribution, but to have some idea of the variability in the measurements. The measurements commonly used in describe such as variability are the range, standard deviation, mean deviation, and coefficient of variation. Characteristics of a good measures of dispersion. An ideal measures of dispersion is to satisfy the following characteristics. The first one, I should be well defined without any ambiguity. Second one, it should be based on all the observation in the data set. The third one, should be easy to understand and compute. The fourth one, it should be capable of further mathematical treatment. Fifth one, it should not be affected by fluctuation of sampling. The sixth one, it should not be affected by extreme observations. Types of measures of dispersion: range, quartile deviation, mean deviation, standard deviation, and their relative measures. The measures of dispersion are classified in two categories, namely as the first one, the absolute measures, and second one, relative measures. First, the absolute measures involves the unit of measurement of the observation. For example, the dispersion of salary of employees is expressed in rupees, and the variation of time occurred for worker expressed in hours. Such measures are not suitable for comparing the variability of the two data sets which are expressed in different units of measurement. The first one, a range. The range defined as the difference between the largest and smallest observation in the dataset. The range R equal to largest value in the dataset L, notation L, smallest value of the dataset, notation S. The range R equal to L minus S, that is the formula. The first one, grouped data. For grouped frequency distribution of the values in the data set, the range is the difference between the upper class limit of the last class interval and lower class limit for the first class interval. The coefficient of range, the relative measures of range is called the coefficient of range. The coefficient of range equal to L minus S divided by L plus S. First example, the following data relates the height of 10 students in centimeter in a school, calculating the range and coefficient of range. The following data, the 158, 164, 168, 170, 142, 160, 154, 174, 159, 146 at 10 height of the 10 students centimeters. Solution: first find out the L value. The largest value of one above the data, the smallest value 142 and largest value 174. The range equal to L minus S, range equal to L minus S equal to L minus S equal to 174 minus 142, that is range 32. The coefficient of range equal to L minus S divided by L plus S. The L value 174 minus S value 142 divided by 174 plus 142. 32 divided by 316, 32 divided by 316 equal to 0.101, that is coefficient of range value. And another example, a discrete data, the continuous data example, the calculate the range and the coefficient of range for the following for the marks obtained by 100 students in a school. The marks, the class interval categories of marks, the number of students, the frequency, 6 to between class interval 6 to 63, 63 to 66, 66 to 69, 69 to 72, 72 to 75. The number of students 60 to 63, the marks number of students 5, and 63 to 66, the number of students 18, 66 to 69 the 42, 69 to the 72, number of students 27, 72 to 75, the number of students 8. Solution, first find out the L and S value. L equal to upper limit of height class. The upper limit of highest class equal to 75. The upper limit of highest class is 75, and the lower limit of lowest class is 60. Lower limit of lowest class is 60. The range equal to L minus S divided by range equal to L minus S equal to the 75 minus 60 equal to 50. The range value 15, and coefficient of range L minus S divided by L plus S, the 15 divided by 70 plus 60 equal to 15 divided by 135 equal to the coefficient of range value 0.111. Merits of the range. Range is the simplest measures of dispersion. It is well defined and easy to compare. It is widely used in quality control, weather forecasting, stock market variations, etc. The limitation of range. The calculation of range is based on only two values, the largest value and smallest value. It is largely influenced by two extreme values. It cannot be computed in the case of open and entered frequency distribution. It is not suitable for the further mathematical treatment. The next topic, the mean deviation. Mean deviation, short from MD, is defined as the arithmetic mean of the absolute deviation of the individual values from the measures of standard tendency of the data set. It is also known as the average deviation. The measures of central tendency is either mean or median. If the measures of central tendency is mean or median, when we get the mean deviation about the mean or median and more. The mean deviation about mean equal to summation modulus D divided by small n. the d equal to x minus x bar. The mean deviation about median, the summation deviation divided by n. The coefficient of mean deviation is the relative measures of dispersion that corresponding to the mean deviation, and it is given by the coefficient of mean deviation, the mean deviation or mean or median divided by the mean or median. For example, the following heights of 10 children, weights of 10 children admitted in hospital on a particular day. Find the mean deviation about the mean, median, and the coefficient of mean deviation. For the following data, 7, 4, 10, 9, 15, 12, 7, 9, 9, 18. The data of heights of 10 children in next solution. First find the number of values n equal to 10. The mean, first find out the mean, the x bar equal to summation x divided by n. 100 divided by n equal to 10. 100 divided by 10. The mean x bar equal to 10. The median arranged data the data is the 4, 7, 7, 9, 9, 9, 10, 12, 15, 18. The n plus 1 divided by 2 with the position. The median 9 plus 9 divided by n plus 1 divided by 2 the position. The fifth value 9 plus 9 divided by 2 equal to 18 divided by 2 equal to 9. That is median is 9. The marks is about the mean deviations. The next one, standard deviation. The standard deviation is the positive square root of average of the deviation of all the observations taken from the mean. It is denoted by a Greek letter of the sigma. The ungrouped data x1, x2, x3, etc. xn are the ungrouped data when the standard deviation is calculated by the first one actual mean.